Hi everyone. So in this video, we are going to be continuing to go over some questions from the review, and we'll be focusing on the questions from the second part of the review. So starting with polar coordinates and then looking at conic sections and then some of the content from 141. So we'll start by looking at number 10, which is asking you to plot some different points in polar coordinates and then convert them to rectangular coordinates. So we'll do A, B, and C. So part A is asking us to, let's just start by actually graphing this. So the point that we're supposed to graph is 3 pi over 6. So basically the way that this works is that the second number tells you an angle. And so you want to go to that angle and keep track of like what direction you would be pointing, right? So pi over 6 would be pointing this way, but let's say instead the angle was, 7 pi over 6, then we would be at an angle here and we would be pointing this way. So you don't want to think of your angle as just being a line. You want to think of it as having kind of a direction associated with it, because that's the direction that kind of tells you where to go to plot your point. So because this number here is 3, we want to go a distance of 3 in the same direction that this angle is pointing. So here's 1, 2, and then we end up with this point here, 3. So that's how we plot the point. How do we convert them between, or how do we convert points between polar and rectangular coordinates? Well, it basically relies upon the fact that, so if we were to look at this angle we graphed here, we have an angle here, which is theta, right? That in this case is pi over 6. And so if we're trying to find the x and the y coordinates, if we take sine of theta, that's going to give us the y coordinate over r, right? Because r is this distance here. So, so basically, because sine of theta is the y coordinate over r, that means that we can write y as r times sine of theta. And I know I'm kind of glossing over exactly where that comes from, but I would just encourage you, go back to the video. I go over this. It's a pretty quick thing, but yeah, it's basically just what I was saying here. So similarly, if we were to take cosine of theta, we'd have this right triangle here, and the cosine would give you the x side over r. And so that means that x is equal to r times cosine of theta. And so you don't really have to do much work to convert from polar to rectangular. You can literally just plug the numbers into this formula and it's not going to give you any difficulty. We saw that going the other way, going from rectangular to polar, there's a few different kind of places you can run into trouble, but that's not going to happen for this. So to convert this into rectangular coordinates, we just need to say, okay, that means that in this case, y is equal to 3 times sine of pi over 6. So sine of pi over 6 is equal to 1/2, so we get 3/2. And then x is equal to 3 times cosine of pi over 6. And cosine of pi over 6 is square root of 3 over 2, so we get 3 root 3 over 2. And so that means that our point in rectangular coordinates is 3 root 3 over 2, and then 3/2. All right, so next one is somewhat similar. The only difference about this one is that in this case, the x coordinate, or sorry, not the x coordinate, the r value is -3. So we're doing -3 pi over 6. So this is part B. So the way we start this off is the same. We go to our angle. We say, okay, we have an angle of pi over 6, so that's going in this direction. But then because our r value is negative, we're not going to go put our point the same place we did here. We're going to go in the opposite direction. So the point is going to be 3 in the direction going away. So it'll be 3 going this way. And so our point will end up being here instead of where it was on the previous question. And then to find the x and y coordinates in rectangular form, it's going to be like exactly the same process as last time. So the y coordinate is going to be equal to -3 times sine of pi over 6. And the x coordinate is going to be -3 times cosine of pi over 6. And so -3 times sine of pi over 6 is going to be -3/2. And then -3 times cosine of pi over 6 is going to be -3√3/2. And so our point is -3√3/2, -3/2. And that kind of makes sense if you compare it to the last one, because the point we found in the previous question was just the positive version of that. And that's because it's really kind of in the same location, but in quadrant 1. So now that we're in quadrant 3, both things are negative, but it's kind of the same position, similar to the first one. Okay, so last one I want to do. This one now has a negative angle, but that really doesn't change much of anything, to be honest. So this one is, sorry, I lost my page here. So this one is 2 -3 pi over 4. So we want to go to our angle, and it doesn't matter if your angle is positive or negative. Like that really doesn't, affect things the same way that having the r value be positive or negative does. You still just want to kind of go to that angle. So what does an angle of -3 pi over 4 look like? Well, pi over 4 would be like here. And then 2 pi over 4, or -2 pi over 4 would be at -90. And so -3 pi over 4 puts us here and pointing in this direction. And so because it's a positive number, we want to go in that same direction. So our point ends up here at a distance of 2. So if both of these were negative, so if it was -2 and -3 pi over 4, that would just mean that our point would be instead in this direction. So we would put it here. So that would be if it was -2, -3 pi over 4. Okay, so now finding the x and y coordinates, we just use the same idea. So y is going to be equal to 2 times sine of -3 pi over 4. And x is going to be equal to 2 times cosine of -3 pi over 4. So what is sine of -3 pi over 4? Well, basically we can kind of use the picture we have here to figure it out. We know that it's going to be a multiple of 45 degrees, and the x coordinate is negative and the y coordinate is also negative. So sine of -3 pi over 4 is square root of 2 over 2. And so altogether we'll get -2 root 2 over 2, which is the same as just -√2. And then for cosine, we'll get, so cosine is basically the same. And that makes sense, right? Because if we look at the picture, they have the same x and y coordinate. So you could draw a separate picture. I just trust that you know how to evaluate sine and cosine of an angle at this point. So you could draw a separate picture on the unit circle if that's what you wanted to do, or maybe you kind of have them memorized, but either way, you just take that number and then multiply it by 2. And so in this case, our coordinates are negative square root of 2 and negative square root of 2. All right, so next up we have some conic sections to graph. So we're going to do 3 of them. So the first one I want to look at is A. So problem A asks us to graph, maybe I'll use a different color here. A is x minus 1 squared over 4 plus y plus 2 squared over 36 is equal to 1. So first question we want to ask ourselves is, what kind of conic section is this going to be? So as soon as you see both x and y being squared, that tells us that it has to either be a hyperbola or an ellipse. So a parabola is only going to happen if only one of x and y are squared. And we'll see an example like that in a minute. So as soon as both of them are squared, it's either an ellipse or a hyperbola. Because it's a plus sign here, that's what tells us it's a ellipse. So this is going to be an ellipse. So how do we figure out what this ellipse is going to look like? Well, basically, there's a couple of steps here. So one part of it is figuring out kind of like what the shape is, so how far it's being stretched horizontally and vertically. And then the other step is figuring out where it's like positioned, so where it has been shifted. So because we're subtracting or adding numbers to x and y, that tells us that we're going to have horizontal and vertical shifts. So we'll get there in a minute, but let's start with figuring out what's going on in terms of the shape. So we can write 4 as 2 squared, and we can write 36 as 6 squared. And so that tells us that our ellipse is going to have, instead of being a circle with a radius of 1, it's going to have kind of horizontally a radius, quote unquote, of 2, and vertically it will have a quote unquote radius of 6. So that will be this kind of oval shape that's taller than it is wide. But the other thing we need to look at here is the shifts that are happening. So with conic sections, because they're set up a little bit differently than functions in terms of where the x's and y's are kind of placed in relation to each other, you can treat x and y the same in terms of interpreting these horizontal and vertical shifts. And sorry, I forgot this. I miscopied this. That should be a 1. So when you subtract a number from either x or y, that's going to be a shift in the positive direction. So if you subtract 1 from x, that's going to be a shift to the right by 1. And then similarly, if you add a number to y, so anytime you add a number to x or y, that's going to shift in the negative direction. So in this case, that means that we're going to shift down by 2. It's kind of like when you have a circle equation, right? And you figure out where the center is by flipping the signs of what's being added and subtracted to x and y. It's really that same idea. Okay, so now we want to figure out, where is the new kind of center of this ellipse going to be? And so we want to go to the right by 1 and down by 2. So it's going to be kind of centered at this point here. The word center doesn't make as much sense as it does with a circle, but it will help us basically figure out like from what point we have to measure to get the shape of this. So in the horizontal direction, we know that it's been stretched by 2. So that means it's going to have a width of 2. And so we're going to go 2 to the left and 2 to the right. And then vertically, we know that it's been stretched by a factor of 6. And so that means we're going to go a distance of 6 up. So you can just count 6 boxes up and 6 down. So that should be here. And so then if you kind of fill this out and make it a circle, sorry, not a circle, an oval shape, that is your ellipse. And I mentioned this before, but if you had been graphing this as a hyperbola instead, it would actually, the process would be fairly similar. So remember with hyperbolas, you end up drawing this like box. So the box you would draw, if this was a hyperbola, would be like this. It would be like the box would have kind of the same shape as the ellipse. And then the hyperbola would be on the outside of the box. So you can kind of think of, in both cases, drawing this like box shape, and for ellipses, the shape ends up inside the box. For hyperbolas, it ends up outside the box. Okay, so next we're going to look at D. So D is asking us to graph this one. So we have y plus 3 squared over 25 minus x squared over 9 is equal to 1. So this is, we know it's either an ellipse or a hyperbola because both x and y are being squared. And because we have a minus sign, that's what tells us that it is a hyperbola. And because the y is the positive part, right? The x is the one that's being subtracted. It's going to be a vertically oriented hyperbola, but we'll get there when we actually get to sketching it. So this is a hyperbola. Okay, so let's start by rewriting it to figure out what the stretches are. And then we can look at how it's been shifted. So we have 5 squared, so stretched by a factor of 5 vertically, and then we have 3 squared, so stretched by a factor of 3 horizontally. So actually kind of similar in shape to the previous one. And then what's going on in terms of shifts? Well, we're not adding or subtracting anything to x, which tells us that there has been no horizontal shift. But we do see that we're subtracting, or we're adding 3 to y. And so that tells us that we have a vertical shift, and it's going to shift it down by 3. So we want to start by kind of placing where that center is and then go from there. So if we shifted the whole thing down by 3, but we didn't do anything left or right, that puts us here. And so now we want to start filling in like the rest of this, this shape. So similar to what we did in the last one, we can say, okay, we have to go 5 to the right and, or sorry, 5 up and down, right? Because that's the vertical stretch. So 5 down brings us down to -8, and then 5 up would bring us up here. So that's 5. And then we go horizontally a distance of 3 in either direction. And so that gives us this box. So I'm going to draw the box in here. And as you can probably see, I was lazy and I just wanted to use one grid for all of these problems. So for this one, it's going to kind of go off the page a little bit, but that's okay. So why do we draw this box? Well, basically it helps us figure out what the asymptotes are going to be for the hyperbola. So you want to draw a diagonal line through the box and then continue it in the same direction. So basically the dimensions of the box kind of determine what the slope will be of this diagonal line. So, you know, the like wider the box would be, then that would cause these lines to be less steep. And if it becomes a more kind of tall and narrow box, then the asymptotes are going to be steeper. Okay, so now that we have that all drawn, now we can go ahead and actually graph the hyperbola. So as we mentioned earlier, because the y part is the positive part, because, you know, we're subtracting the x squared, that tells us it's going to be a positive, or sorry, a vertically oriented hyperbola, meaning that the two different halves of it are going to be on the top and the bottom of the box. So we want to just kind of draw them so that they look kind of like parabolas, I guess, but they get these kind of flat edges as they get closer to the line. They really kind of start to look like lines themselves. Oops, that one wasn't so good. And that's it. All right, one more. Okay, so last one we're going to do is f. So f is asking you to graph x plus 2 is equal to 2 times y minus 1 squared. So this one, because we are only squaring y, there's no x being squared, that tells us that this is going to be a parabola, and it's going to be a sideways parabola. You know, it's not going to be the shape that you learned in like your algebra classes. It's going to be a sideways parabola. So similar with the other ones, we want to look at the numbers that we're adding and subtracting from x and y to tell us what the shift is, because for a parabola, that tells you where the vertex is. So we see that we shifted, because we're adding to x, we are going to shift to the left by 2. And then because we're subtracting 1 from y, that means that we're going to shift up by 1. And then there's one other thing going on here, which is that because we're multiplying by 2, this is going to have a vertical stretch. I guess I shouldn't say vertical because it's a sideways, but maybe I'll just say stretch by 2. So basically when I say a stretch by 2, I mean that if you kind of picture a parabola that is kind of a normal, an upward facing parabola. If you stretch it by 2, it becomes 2 taller. That's the same kind of shape this is going to have, but it's going to be on its side. So I would think of these like stretches or compressions that happen, and we won't be dealing with these with like horizontal stretches and compressions or like numbers here. You want to just think of them as like, I would just have an idea in your head of what like a standard parabola shape looks like, and then just think about how that's getting stretched. Okay, so where is the vertex of this? Well, because it's been shifted left 2 and up 1, that tells us that the vertex is here. So if this parabola had not been stretched, then it would have a shape like this. It would go over 1 and up 1 in both of these directions, and then kind of continue with a shape like this. But this has been stretched by 2, and so that tells us that we should, instead of going like up 1 over 1, we should go up 1 over 2 and down 1 over 2. And then typically the next step would be going up 1 over 3. Now we want to go up 1 over 6 because it's become twice as kind of stretched. And then down 1 over 6. And so our shape ends up looking like this. All right, so that is it for conic sections. So now we're going to look at some stuff that is review from 141. So we're going to start with some kind of like algebra, function notation stuff, and then we'll also look at some solving of equations, and finally, what's the last thing? Some stuff using a graph. Okay, so first one I want to look at is number 12. So number 12 gives us two functions. It says f of x is equal to 3x squared plus 2x minus 1, and g of x is equal to x minus 1. So this question basically asks you to just kind of do a bunch of different things with these functions. And, you know, it is required for us to put 141 stuff on the final. And I really tried to pick out, you know, deciding what 141 stuff to put on the test. I really tried to pick stuff that I think is the most important stuff to know how to do for calculus. So for calculus, there is going to be a lot of like understanding how composite functions work, understanding how it works to plug something into a function other than just x. And so that's the reason that I put this on the review, and that there will probably be something along these lines on the actual test. So the first question is to find f of 2x. So what does it mean to find f of 2x? It basically means that, you know, if you look at this original equation, whatever you're putting in the parentheses, that is what you're replacing x with, right? So for example, if you were evaluating f of 5, you would do 3 times 5 squared plus 2 times 5 minus 1. And so whatever you put in these parentheses, you just want to replace x with that. And really the only thing we have to be careful about here is our use of parentheses. So whenever you're substituting something in that isn't just x or isn't just a number, a positive number, you want to make sure to put parentheses around it. So here we'd want to say 3 times, in parentheses, 2x squared. Because we need to make sure that, you know, this function is supposed to take x and square it. And so whatever you're plugging into the parentheses, that whole thing needs to get squared. And then we have 2 times 2x minus 1. So now we want to simplify this. So what is 2x squared? Well, that is the same thing as 4 times x squared, right? Because 2x times 2x gives you 4x squared. And then here we get 4x, and then we get minus 1. So altogether, this gives us 12x squared plus 4x minus 1. Okay, so part B is similar and actually just a little bit easier, so I'm going to skip that, but let's look at part C. So C is asking you now to find f of g of x. So what does that mean? That means that we're taking f of x, the function f, and we're, instead of plugging in x, we're plugging in g of x. So how do we figure out what that actually means? Well, we want to take where I wrote g of x here in green and replace it with what g of x actually is. So g of x is x minus 1, right? Because we know up here, g of x is equal to x minus 1. Maybe I'm going to use a different color. Just mix things up a little bit. Okay. So that's where that's coming from. And then how do we evaluate f of x minus 1? Well, now we're going to take that function f, and everywhere where we see the x in there, we're now going to replace it with x minus 1. So we have 3, and this is where, again, the parentheses are really important. We replace x with x minus 1, and then we have 2 times x minus 1, and then we just have minus 1. So everywhere we see the x, instead of x, we're putting x minus 1 there. So the reason the parentheses are important is because we now need to actually, in order to simplify this, we need to multiply out x minus 1 squared. So just to quickly remind you, it is not true. X minus 1 squared, that is not the same thing as x squared minus 1 squared. Why is that? Well, because what does it mean to square something? It means to multiply it with itself. So what is x minus 1 squared? It's x minus 1 times x minus 1. And so that's how we need to figure out what to actually put there. So x minus 1 times x minus 1, and I dislike now that I'm using this color that I usually use for things that are wrong. So let me change it to orange. So x minus 1 times x minus 1 is equal to x squared minus 2x plus 1. And so that's what we're going to put in up here. Oops. Here. So that's going to give us 3 times x squared minus 2x plus 1 plus 2 times x minus 1. So that's 2x minus 2 minus 1. So this, when we distribute the 3, we get 3x squared minus 6x plus 3 plus 2x minus 3. And so altogether, this simplifies to give us, let's see, and I feel like I made a mistake somewhere because this doesn't agree with my answer. But it's possible also that I made a mistake on the solutions. Let me just quickly double check. That's all right, right? And we just replaced that with that. I think I might have made a typo on my solutions. So we get here 3x squared minus 4x. So that part agrees with the solutions, but then it looks like we should be getting just plus 0, right? Unless I'm missing something. So I think this is right. Sorry, I'll leave a note if I made a mistake on this. I might just be tired and having making a mistake, but let's just stick with that for now. Okay, so the next one is asking us now to find instead g of f of x. So it's basically asking us to do the reverse. So now we're going to take the function g. So g of x was equal to x minus 1. And instead of putting x in, we're going to put f of x in. So what's the function f of x equal to? F of x is equal to 3x squared plus 2x minus 1. And so the function g is supposed to take whatever is in the input and subtract 1 from it, right? So in this case, what we'll be doing is we'll be doing 3x squared plus 2x minus 1 minus 1. And it looks a little confusing, but like literally all we're doing is we're taking the rule of the g of x function, right? The g function says take your input and subtract 1 from it. And we're just replacing that whole, you're replacing x with this whole function. And so this simplifies to 3x squared plus 2x minus 2. All right, one more I want to look at is f of x minus g of x. So this one's a little bit easier. So what does it mean to do f of x minus g of x? That just means you're going to subtract the functions. So I just wanted to show this just to kind of contrast it with the other ones. So f of x minus g of x would be now doing 3x squared plus 2x minus 1. The one thing you have to be careful about here is that you want to put parentheses around g of x to ensure that you're subtracting that entire function. So this first one is f of x, the second one's g of x, and we're putting parentheses around g of x. And so we end up with 3x squared plus 2x minus 1 minus x plus 1. And altogether that simplifies to 3x squared plus x. Okay, so that's it for that question. So next we're going to look at solving some equations. of various kinds. Okay, so I want to start by looking at C. So C is asking you to solve 2 to the x minus 1 is equal to 10. So how do you solve exponential equations, I guess, or equations that look like this? We basically need to find a way to get that x out of the exponent, right? Right now, you just, like, if you think of all the different things you know how to do when solving an equation, you can't really do them when x is like stuck up there in the exponent. And so there was a trick that we learned in 141, which was using logarithms. So remember, there's a logarithm rule that says if you take a log base b of a number, I'll just say here, I'll say a, to a power n, that's going to be the same thing as bringing that power down and multiplying it with log base b of a. And by the way, the videos, so the sections that we did on exponential equations and logarithmic equations, that was at the end of last quarter when we were doing things virtually already. So if you go back on and look on my channel, you should be able to find some videos that go more into depth about this if you like totally forget it. So yeah, so basically what we're going to do is we're going to take advantage of this rule. And how can we take advantage of this rule? Well, we need to take a logarithm of both sides of the equation. That's really the only way that we're going to be able to bring that exponent down. So you can use any kind of logarithm you want, but because of how calculators are set up, you typically either want to use ln or log. And actually in this case, it might make a little more sense to use log. And the reason for that is that log is log base 10. And what makes me say that? Well, it's basically because we have 10. So log of 10 is going to be a lot more simple, but you would be completely fine. You would get the exact same answer if you used ln. So don't worry about if you want to do it that way. And it looks like actually in my solutions, I used ln. So you can look at that and see, if your answer matches that, then you're good. So the whole reason behind doing this is because it now lets us bring down this x minus 1. So we have x minus 1 times log of 2 is equal to, and then, so what is log of 10? Well, log of 10, so if there's no number written as your base, that means log base 10. So basically this is the same thing as saying log base 10 of 10. So how do logarithms work? They're basically asking you to find an exponent, right? So log base 10 of 10 is asking you, what power do I need to raise 10 to get 10? So logarithms are always asking you for the exponent that you need to go from the number down here to the number up here. And in this case, they both happen to be 10. So what is that mystery exponent? It's just 1, right? If you raise 10 to the 1 power, that gives you 10. So we're trying to solve for x. You could distribute here, but you're going to find it to be, I think, a little easier if you instead leave the x minus 1 together and just divide both sides by log of 2. So we have x minus 1 is equal to 1 over log of 2. And then if we're trying to solve for x, all we have to do is add 1 to both sides. So we have 1 over log of 2 plus 1. And then you can just type this into a calculator and you'll find that it's approximately equal to, 4.32. And if you look in the solutions, it says ln of 10 over ln of 2 plus 1. And again, like I said, it's equivalent. It looks different, but if you type it into a calculator, you'll see that it's actually equal to the exact same thing. Okay, so part D is a different kind of equation. So this one is now what's called a logarithmic equation. And so it's called a logarithmic equation because our variable is now inside of a logarithm. So really answering or solving this equation, all you really have to know is what does a logarithm mean? That's really all you need in order to solve this equation. So in general, if you're taking a logarithm with some base of some number, let me just say x here, and your result is equal to some other number that we'll call y, that is equivalent to, so this double-sided arrow means is equivalent to, saying that b to the y is equal to x. And that is just literally the definition of a logarithm. Like, that's what a logarithm means. Because as we said above, a logarithm is asking, what power do you need to use to get from this number to this number? And so the answer is this number. And so that means that the base to the answer is equal to whatever number was inside of the logarithm. So in this case, really all we have to do to solve this is to rewrite it as an exponential statement instead of a logarithmic statement. So if log base 2 of x is equal to 3, that must mean that 2 to the third power is equal to x. And so what is 2 to the third power? It's 8. So that means that x is equal to 8. And that makes sense, right? Log base 2 of 8 is equal to 3. So that solution is correct. Okay, so next up we have part E. So this one is asking you to solve x times e to the x plus e to the x is equal to 0. So with basically any equation that is set equal to 0, the first thing you want to see is, can I factor? If you can factor anything out, that will help you, because when you have an equation equal to 0, you can solve using the zero product property. So in this case, what can we factor out from both of these? Well, they have a common factor of e to the x. So we can pull out an e to the x, and we're left with x plus 1. So anytime you have two things being multiplied together equal to 0, that means one of those things equals 0. So e to the x equals 0, or x plus 1 is equal to 0. So e to the x can never equal 0. That's like a really, really important fact to just kind of know. And it's because e is a positive number. E is 2.72 approximately. And so try as hard as you can. You're never going to find a number that you can raise it to and get 0 as your answer. You might guess 0, but any number to the 0 is equal to 1. So it just doesn't work. So this part has no solution. And that doesn't mean that the whole thing has no solution. It just means that the solution is not going to come from this equation. So what is the solution? The solution is going to be x is equal to -1. And we can even check that that works, right? So if you plug in -1 for x, you would get negative e to the -1 plus e to the -1. And so you would get 0. All right, last one, kind of similar, even though it looks different. So this one is x cubed is equal to 9x. So I want to start by telling you how you should not solve this equation. So you might think, well, okay, I have an x on both sides, but so why don't I just divide both sides by x? So if you tried to say x cubed is equal to 9x, and then you said, I'm just going to divide both sides by x. So you would get x squared is equal to 9. And then depending on how insightful you're being, you might even just say, oh, the answer is just x equals 3. Or you might realize that actually x could also equal -3. But those are actually not the only two answers. So this is not really the right way to solve this equation. And the reason is that you cannot divide both sides of an equation by a variable without losing potential solutions. Because basically when you divide both sides by x, you're making an assumption that x is not equal to 0, because you're not allowed to divide things by 0, right? So if you're dividing both sides by x and you're saying that's a valid thing to do, then you're somehow in there, you're making the assumption that x is not equal to 0. So what we want to do instead is subtract this 9x from both sides and factor. So generally speaking, like it's usually a good idea for equations to get them set equal to 0 and then solve by factoring. So in this case, we can factor out an x. And we have x times x squared minus 9. And then we can go a step further, because x squared minus 9, that's a difference of squares. That factors as x plus 3 times x minus 3 is equal to 0. So this gives us three options. X is equal to 0, x plus 3 is equal to 0, or x minus 3 is equal to 0. And so we have one solution already is x is equal to 0. Another solution would be x is equal to negative 3. And the third solution would be x is equal to positive 3. So it's not like the solutions we got in that, the way I did it in red on the side, it's not like they were wrong, but it wasn't all of the solutions. And I think it just makes it a lot easier to kind of forget about the solutions when you try to do it that way. Okay, so last question we're going to go over is going to be some questions related to this graph. So this is another thing I'd say, even actually of everything, this might even be the most important thing to understand for calculus, because there's going to be a lot of working with graphs of functions and being able to kind of interpret what you see in the graph in terms of, is it increasing or decreasing? Is it positive or negative? Things like that. So this function we're calling g of x. So the first question is find the local maxima and minima of g of x and the x values at which they occur. So this is something we talked about in 141. So a local maximum or a local max is basically what I would call a peak or a hill in your graph. It's a place in your graph that kind of looks like that. A local min is what I would call a valley. So something that looks like that. And basically, why the word local? Well, because, for example, so maybe let's start to answer this question. So this point here is a local max, right? Because it's a hill. So why the word local? Well, that's not the very highest point in the whole graph, right? The graph keeps going up this way. There's plenty of points that are way higher up than this point. But if you were to kind of crop this graph, like let's say you were to crop it so that this was the whole graph, well, then it would look like the highest point, right? So that's where the local comes from. It's like in its neighborhood, it's the highest point. So the way that we would word this kind of correctly would be to say that we have a local max of 4. Because the maximum value, like when you're talking about the value of a function, that should be the y value. And then we say that happens at x is equal to 1. And then similarly here, we have a point down here that looks like a valley. And so that is a local min. And that one has a y value of 0. And that happens at x is equal to 3. So we'll see that in calculus, we'll talk a lot more about local maxima and minima towards the end of the class and basically see how you can find them even without looking at a graph. So we'll see that the stuff we'll learn in calculus basically ties in quite closely to local maxima and minima. All right, so next question we want to answer is find the intervals of increasing and decreasing. So increasing and decreasing basically just means, is the function going up or is it going down? So let's start by looking for places where the function is increasing. So increasing means from left to right, it's going up. So the graph is increasing, increasing, increasing. When it hits a point where it flattens out, that is not included anymore in your interval. So we'll stop at 1 and not include 1 in our interval. And then it starts increasing again at x is equal to 3. So we want to give our answers in interval notation. So we would say that our function is increasing on the interval from negative infinity because it kind of keeps going down in that, or it has the same shape going off to the left. So it's increasing on the interval from negative infinity up until 1. And then also the interval from 3 to infinity. So one really important thing here is that notice I'm giving x values. I'm not giving the y values. And that's because the x values are really like how we kind of measure the, how we describe how things are happening in the graph. And the analogy I would give is imagine that this was a graph that represented temperature as time went on. If someone asked you, when is the temperature increasing? You would give them temperature, right? And temperature would be on the x-axis. You wouldn't say, oh, the temperature is increasing from 0 degrees to 30 degrees. You would say the temperature is increasing from 1 to 4 p.m. or whatever. So the x-axis is where we really kind of keep track of time or location of things happening. So for decreasing, we just want to look at where is the graph going down. And so that would be just between those two. So that would be decreasing on the interval from 1 to 3. And one other thing I want to mention here is that notice that we're not including the endpoints. So we're using parentheses, and that's because when the graph is kind of flattened out or when it's transitioning between increasing and decreasing, it's neither increasing or decreasing. So we just don't count those points at all. So x is equal to 1 and x is equal to 3, those are turning points. Those are not places where it's increasing or decreasing. Okay, let me erase some of this because I think we'll want to draw some more stuff. Okay, so next question is asking us for what values of x is, or no, sorry, wrong question. I jumped to the next one. So this next question says actually find the average rate of change of g of x from x is equal to 0 to x is equal to 2. So what is average change all about? It's basically looking for kind of the average slope. So slope is a thing that is really only used for lines. It doesn't really make sense to talk about the slope of a graph that's all curved like this. But when we're talking about average rate of change, it's a way for us to actually use the idea of slope to kind of approximate what's going on in this graph. So if we look at this graph, if we look at the places where x is equal to 0, so that would be this point here, and then the point where x is equal to 2, the average rate of change is going to be the slope of this line. It's called the secant line, the slope of the secant line from 0 to 2. There's also a formula for it. So and the formula isn't something you really have to memorize because it's the same as just finding the slope of the line I drew there. So, but let me kind of write this down in a couple of different ways. So the average rate of change from x is equal to 0 to x is equal to 2, that's the same thing as the slope of the secant line. And by the way, this whole secant line thing, that's something that we're going to talk about a good amount at the beginning of Calc 1. And this idea of finding average rate of change is actually going to be pretty important in calculus. And so how do you find the slope of a line? Well, you look at the y coordinates minus, like you subtract the y coordinates in the numerator and subtract the x coordinates in the denominator, right? That's just like how you find the slope of a line. So what are the y coordinates in this case? Well, they're going to be f of 2 and f of 0, right? Because if the x coordinates are 2 and 0, to find the y coordinates, you just plug them into your function. So to find this actual slope, you could, plug these numbers in, or you could just kind of look at the graph and read the slope, but let's just kind of keep doing it this way. So f of 2 is actually equal to 2 on this function, right? It looks like if you plug in 2, you get 2. So f of 2 is 2. F of 0 happens to also be 0 because the graph goes through the point 0, 0. And so we end up with 2 over 2, which is equal to 1. So that is the average rate of change. Or you could just look at this line that we drew and say, well, it has a slope of 1. All right, next question is asking us for what values of x does g of x equal 4? So what is this asking you? Well, basically, g of x equaling 4, that means that y is equal to 4, right? Because g of x is the output of the function. And so we want to go to our function and we want to look at what are the x values of the points that occur at a height of 4. So one way to do that is to draw a line at a height of 4 and just kind of see like where does that cross the graph. And so we can see that it happens at x is equal to 1. That's one place where the height is 4. And the other place is when x is equal to 4. And so our two answers would be x is equal to 1 and x is equal to 4. So, I could also ask a different question. I could say, find g of x when x is equal to, let's say, 3 or something like that. That would be asking you the opposite. So if I tell you the value of x and you're trying to find the value of g of x, well, that would mean go to that x value and look at the output. But because this one is giving you the output and you're looking for the input, that's why you're kind of looking at a particular height and figuring out what are those x values. All right, last question is asking us for what values of x, I guess I said for which values of x is g of x greater than 0. So what does it mean for a function to be greater than 0? Well, that means that it has to lie above the x-axis. Right, because the x-axis, so if the question was asking for g of x equals 0, then we would be looking for points on the graph where the height was equal to 0, and that would be like this point here and this point here, right? Those are points that are at a height of 0. But the question is asking for where is the function greater than 0, and so we're looking for parts of the graph that lie above the x-axis. So the first part of the graph that lies above the x-axis is everything between these 2 points. And I'm putting an open circle on them because at those 2 points, the function actually does equal 0. And we want the function to be greater than 0. And so basically anything between these 2 points is going to work. And then also anything from 3 on is going to work. And so those are the intervals we're going to want to write down. We're going to want to write down what are those x values where this is happening. So this first part is everything from 0 up until 3, all the x values between 0 and 3, not including 0 and 3. So that's going to be the interval 0 to 3. So careful when, I think sometimes when you write down intervals, it looks like you're talking about a point, but usually you'll be able to tell from context. So this is not referring to a point, this is referring to intervals. So maybe I'll say that to be really explicit here. So on the intervals 0 to 3, and then what was the other interval? It was from 3 onward. And so that would be 3 to infinity. All right, so that is it for this video. If you have any questions that were not answered by this video, definitely feel free to email me and I will help you out. Good luck with your studying, and I guess this is my last video for the quarter, so I will see some of you next quarter, and